Hi everyone, welcome to this video. In this one, I've decided to get on here and discuss the topic of testing FastAPI applications using PyTest. This video is made with the goal of at least helping you understand the testing concept. And what we're going to be doing is not specifically unit testing, but we're going to be majorly doing sort of like an integration test, because what we're going to be doing is using the FastAPI TestClient to test the different parts of our API or the different API endpoints. And with this test client, we are going to be looking at how we can look at responses and what is returned in those responses. We're going to test things such as data validation and so on and so forth. With that, we're going to be looking at very many interesting PyTest features that are going to help us to learn more about PyTest and how we can use those to basically work with other technologies. What I'm meaning is, with what I'm going to be teaching here, you can pretty much apply the knowledge in other frameworks or other tools and so on. I just hope that you learned from this video, and I would like to request that you leave a like on this video, because that's how these videos can get to many other people. So without wasting your time, let's just get into the video. To follow along with this video, you'll need to first of all find the GitHub repository that I've linked down in the description box, and that's where you'll find the source code for both examples that I'm going to be sharing. The first will be the simple API that uses an in-memory list database, and that will be on our master branch, which I actually forgot to rename to main. And then the other one will be the with DB branch that has the source code for the API that will have a database and some dependencies. So I think you'll need to clone that for you to be able to follow and install the requirements. I also leave how to install most of the stuff you'll need to run this demo. All right, let's get started. So the first example is going to be a very simple API, and that's going to be a very simple CRUD API. This CRUD API is making use of our in-memory list database, which is actually not in memory because I added some data. If I go to our VS Code right here, we basically have a simple FastAPI app, and it has a source folder containing all the source code. And in that, we have a danda init.py where we create the main application instance. So one thing to note is that all our routes for books are going to be found in a router. So if we go to the books.py module right here, we'll be in position to see our book router, and on that book router we registered all the API endpoints that are specific to books. Now for our case, we are just carrying out simple CRUD. There's nothing going on so much. We are using this list of books which is found in data.py, and with that we are basically carrying out CRUD. So this list already has some data, and the structure of that data is that each book is going to have an ID, each book will have a title, each book will have an author, a description, a level, the date published, and the status. And then we also have schemas, and these schemas are basically ways we can validate our inputs to all the requests that are needing input data. For example, the create and the update, and then we have the response schema, which is necessary for us to show or present our data in a format that shall be able to understand by any client. We also have an enum that we set up here, and this enum is going to be responsible for helping us to keep ourselves locked to a list of options. So for example, we have public and private books, so users will be able to achieve some filtering on the front end when retrieving all these books. All right, so let's get started testing this simple API. Now, one thing we need to start is going to be PyTest, because it's going to allow us to run our tests. If you haven't installed PyTest, you need to run the command pip install PyTest, and that will be just enough for you to install PyTest in your virtual environment. So I already have it installed. Now the next thing I'll have to do is to set up my tests. So to set up my tests, I'm going to go ahead and create a folder called tests. Now this is very necessary if you are going to have very many tests I'm going to create this folder called tests, and to make it a Python package, I'll have to create a danda init.py file. And in this danda init.py file, I am going to go ahead and just close it because there's nothing it's going to do. It's just going to allow us to be in position to import stuff from other modules or from other packages. Another thing I'm going to do is to create a file, and this file is going to be, so I'm going to create a file and I'm going to call this conftest.py. So conftest.py is going to be the file that is going to have everything we shall need to set up our tests. Now, PyTest works with fixtures, and fixtures are basically functions that help you define objects that are going to set up your tests. So there may be those objects or those variables that you're going to use, or values you may use to run every test. So for example, in this case, we're going to be using FastAPI TestClient, and this test client is an object that is going to be shared across all tests. So the test client is simply sort of like a virtual browser that helps us to make requests to our API without running our server. So I'm currently having my server running, and this is what is going on. If you're wondering how I ran it with a FastAPI CLI by running FastAPI dev and then source, pointing to the source directory. Now, since our app instance is found inside that init.py, it's able to recognize that source is the folder in which our app instance is. Now, to go back to what we're talking about, conftest is where we write our fixtures, and fixtures are just functions that help us to set up our tests or create these objects that will be shared among all tests. Now, to begin, we're going to create our test client object, and then we shall share it across all the other tests that we're going to be writing in this video. So to start, we shall import the test client class from FastAPI, as that is what will allow us to create the test client that will help us to make requests to our API. So I'll say from FastAPI, we're going to go ahead and actually access the test client module. And inside test client, we shall go ahead and import the class that's called test client. Another thing we're going to need is going to be the app instance, because the test client allows us to create a client object, but then this client object has to be attached to our application instance. So I'll have to go ahead and say from source, we are going to go ahead and import app. So by doing this, I'm actually meaning that we're going to go to our danda init.py inside our source folder, and that's where our app instance is going to be located. So once that is done, I will go ahead and also import pytest, because that's what we're going to be using to create our fixtures. Now, to create a fixture, all we have to do is to make use of pytest. So we just have to say pytest.fixture, and this will go ahead and decorate any function that you want to create as a fixture to be a pytest fixture. Now, in this case, we always name these fixtures with whatever object we are going to return. Now, the object I want to return, I'm going to call it a test client, and therefore that's why I've called this function test client. But you can feel free to call it whatever you want, as long as you're going to always remember how you call it. And once I've done with that, then I'll go ahead and create our test client. So I'll use with, or I'll create a context manager here, and I will say with test client, and then we shall provide the application instance, and then shall just basically call this the client object. Then shall use a yield to generate the client value. So one thing to note here is that this test client class is a subclass of the HTTPX client class. Now, if you're familiar with how HTTPX works, you always create a client and then use that client to access the different HTTP methods. You can provide headers, you can provide cookies to any requests you want to make. Now, one thing that this takes in is the app instance, and that has to be the ASGI app instance. For our case, our ASGI or our ASCII app instance is going to be our FastAPI instance, and therefore if we provide it there, we shall then create our client object. So this is just enough for us to have our first fixture. Now this fixture is going to be used across all the tests we're going to write for this demo. So I'll go back to our code right here, and then I'll create our first test file. Now keep in mind that all our tests are found within the folder tests, and then we'll have to name every test file with the structure test underscore and then the name of whatever I want to test. Now in this case, I will be testing the books module, so I'll say testbooks.py, and then inside there is where all our tests for books are going to be located. Now let us write our very simple test. If we go back to our Swagger UI right here, we can manually test our endpoint. For example, if we try it out, we can execute. So that's the first scenario where we do not have any status query parameter provided. So this will be one to return all books. We can see the amount of items that are returned right here, and since we know the number of items we are returning, we can be able to make our assertions based on that. So 1, 2, 3, 4, 5, 6, 7, 8. Those are the number of books we have in our list. So we can be in position to carry out an assertion such as that. If we're to go back, let's write our first test. So we can call this the first test. That's going to be to test when we are returning all books without filtering. So in this case, we can write test get all books. Now keep in mind that for PyTest to recognize it as a test, you still have to have test underscore as the name of the function that you're using as your test. And once that is done, then we'll need to go ahead and write our test. So I'll pass this for now. Now remember the fixture that we created in our conf_test.py. This fixture is always going to be passed as a parameter to the functions or the test that will be using that specific fixture. So if we go ahead and provide it here, then we'll have access to the test client. So for as long as we place it in conf test, it is accessible without importing in every test we shall be writing. So let's go ahead and use it. Now, to make a request to our API, we're going to be returning a response object. And that response object is going to be kept in a variable called response. And then that will be the result of using our test client object to make a request. So we have to specify an HTTP method. For our case, that HTTP method is going to be the get method, and then it's going to be to a URL, and then we shall provide all the other needed arguments. So to start, I will first of all specify that our base URL is going to be the URL on which all our books endpoints are going to be located. And if we're to go back to our Swagger UI right here, we can note that all our books are starting from the prefix /books, because that's what we actually set up in our danda init.py to be the prefix of all books that are ran on the books router, or all the endpoints that are located on the book router. So if we are to go back here, what we can do is to set this to be /books as our root endpoint, and then we can go ahead and basically make all our requests to that endpoint, or starting from that endpoint. So I'll create an F string right here, and then I'll go ahead and provide the base URL. So this is going to be the root endpoint. And since we do not have any sort of authentication or headers we want to set up on this request, then we'll just leave it like that. So this is just a simple GET request made to the root endpoint, and this will return all books. Now, one thing to note is that when we are testing, we're going to make assertions, but these assertions work in the following way. You always have what is going to be the result of carrying out the calculation or carrying out the operation that you want to carry out, and then you'll have what you expect. So you're always going to compare between what is going to be the result and what is going to be expected. So what is going to be the result is what will happen when you call the endpoint, or what will happen when you make use of the code that you've written, and then you'll have a value or a result in mind, and that's what you expect. So in our case, we are going to assert, and then on the left, we are going to provide the status code, because that's the first assertion you're going to make. So we have a status code that's going to be returned from this response. So that's going to be response.status code. And then on the right, we're going to have the status code that we expect from this request if everything goes as planned. So in this case, we are going to use FastAPI status module to access our status code. So I'll say from FastAPI, we are going to go ahead and import status. And once we've imported status, we can then go ahead and check if this is going to return the default status of HTTP 200. Okay. So if everything goes as planned, this response should be returning a status code of HTTP 200. Okay, and that's exactly what we are testing. So to work with that, then we need to go ahead and run our tests. If I go back here, I'm saying pytest is not resolved, but I think that's more about how my Python extension is not recognizing it, and yet it's installed. So let's go ahead and test. We'll go back to my terminal right here. I will first of all check if I am in my virtual environment. So I'll do something like which pip or which Python 3. So I'm in my virtual environment, and if I pip list, and to see if my pytest is located in the correct folder. So pytest is installed in the right folder. Now if we run pytest, this will go ahead and collect our tests and then run them, and then show us which tests have passed or failed. So for our case, we are seeing that our one test, which is our test box, has passed, and we can even get some more information about our tests. For example, we are saying that the only test we have is test/testbooks.py, and our test has passed, which is the test to go ahead and get whole books. So we are actually okay doing that. Now, another assertion you can make here is assert. So we can check for the length of the response. Now, if we expect this to return all the books that we have in our list, then we can just easily compare that length with the length of the books, because I have that in data.py. So since these are 8 items, I can easily go ahead and make that assertion to check if all the books that the API will have at first will be the ones that will be returned. And in that case, if we go back here, we can just say length of books, and then we can import books. So I can say from source.data, we are going to go ahead and import our books. So once that is done, I can simply go ahead and run my tests, and then we see object of type response has no length. So I'm supposed to actually do response.json, because that's what we return, the list of books. And that will run our tests. All right, so at this point we have our first test running and everything is fine. Now, one thing that we also need to do is to check if our tests are actually covering our code. Now, there's this term called coverage, which is basically a measure of how much your tests are covering your code. So you always want to keep track of your tests and also check if your code is actually being tested, or how much your tests are affecting the code you've written. So for our case, we are going to install pytest coverage, which is basically a package that works together with pytest to give us a report of how much our tests are actually working on the code that we are testing, or the API that we are testing. Now in our case, we're going to do this with pip install pytest curve. and then that will give us the ability to run PyTest and then get a report of how much we have not yet tested or how much we've so far tested. After installing that, I will update my requirements.txt with pip freeze requirements.txt, and that will be it. So to run PyTest with coverage, we then need to go ahead and run pytest --curve, and then we shall run our tests. By this time, we shall get a report of how much our code is being tested. So for now, we see that we are getting 71% test coverage, and then our sourcebooks.py is only tested 44%. So we still have a long way to go. Now, one thing you can do is to, since this pytest coverage package comes with coverage, which is basically the most popular way to find out code coverage in Python, it comes with a command coverage. So this command coverage allows you to run commands just like you can run with Python, but then it also helps you to generate the coverage and also show that coverage in reports that are visually appealing. And you're going to see what I'm actually talking about. So with this command, we can do something like coverage HTML, and then actually I just intended to run coverage help, and this will show us the different commands. But inside those commands, we have those to show us reports. For example, the HTML report, the JSON report, and then LCAV report, and so on. Now, let's go ahead and generate an HTML report. So to do that, we shall just do coverage HTML, and this will go ahead and generate HTML curve, which is a folder in our project, and then index.html. Now, always keep in mind that this is something we have to ignore because we do not want to add it to our Git folder. I think I already ignored it. So if we are to go to that folder, we're going to collapse this, and then I don't think that is actually, let me just see. HTML cover, I guess I'll have to refresh, and more folders have been added here. So if I go to HTML curve and go to index.html, I'll open it using an extension called live server, and that will start a server. So if I go to my localhost 555 and I open it in the browser, I want to go to the HTML curve folder, and this is what we shall get for our report. Now, what we are interested in is checking if we are writing tests that are actually covering all of our code. And in this case, the main file that we are testing is the sourcebooks.py that contains the endpoints for the CRUD. So if we're to go inside that folder, we now see that we have covered some parts of the code, but we haven't yet covered others, and we still have other things to test. So just like you can see, each part that is in green will be covered by our tests, but then each part that is in red has not yet been covered by our tests. Now that means we have to go ahead and write the tests that will be necessary for us to go ahead and cover or be assured that all our code is working as expected. Now, when you go back to our VS Code, I will go ahead and close this and also close my terminal, collapse everything. We have to go ahead and also test the different scenarios. So for this simple endpoint, we've so far tested how we can make a request to get all books and get all books from the database. However, we may also want to test books that are, let's say, private or public, and those are the scenarios you may want to keep testing. So for example, if we are to go back to our API, we have filtering, in which we can filter this list of objects or list of books by using a status that we pass in as a query param. Now for that case, you want to go ahead and do something like this and execute, and then you'll see that you're returning public books. And when you check the request is one in which you are actually making a request to that endpoint, but then you're providing a query param, which is public. So let's go ahead and also write that test. So I'll go back right here, and what I'll do is to just simply copy and paste this test. If I provide this test, then I'll change this from getting all books to getting public books. And then here we need to modify this test client request to make sure that we are providing that optional query param. Now, since this is an HTTPS client object, we can easily pass the params keyword argument, and this will allow us to create a dictionary with the key being the name of the query param we want to pass. So in that case, we shall say status, and then the value for that will be public. And in this case, we can now go ahead and also check for the status code. But this case, the amount of books that will be returned will be 4. So that's what I want to go ahead and check. I'll do the same thing for all private books and then run our tests once again. So if I go ahead and change this, I'll go ahead and change this to private. And then I'll also change my query param to private. And then since I have a knowledge that my books that are private are 4 and my books that are public are 4, I will be in position to go ahead and run that test successfully. I may also want to test and check if my API will behave in a way that it will throw a 422 unprocessable entity in case I provide, let's say, an invalid status that's not part of our allowed statuses. So for us to be able to do that, I will go ahead and also do the same thing, but with an unknown status. So in this case, I may do something like an unknown, and I'll go ahead and also change the status code. So in this case, I'll go ahead and change the status code to HTTP 422 unprocessable entity. So if I go ahead and run this code, so I'm still getting a 200 here. I'm not really sure why, because this is supposed to be failing. Oh, I think because I forgot to name the status. So in this case, I'll have to rename the name of the function to get books with invalid status. So that's what I'll give this. So I'll say something like get all books with invalid status. And when I run this, the test is still failing. So let's check what is happening. So if I pass in params that, so the mistake was coming from how we named the status, which was supposed to be private, but in uppercase. So since the statuses were case sensitive, that's why we got that error. But then if we run our tests again with pytest --curve, we'll now see all our 4 tests passing. And if we go ahead and create our coverage report with coverage HTML, we'll then go back to our browser right here, and then we'll see that that specific endpoint we are testing has been fully tested. So now we have the work of going ahead to test all these other endpoints. And to save time, I have done all the tests and they are present on the GitHub. So if I went ahead and pasted them right here, and save, we'll now try to run the test once again to cover all the other endpoints. And then the test will pass. So if we go back to generating our coverage report, we'll go back to our browser. And this time when we refresh, we shall see that all our tests have been passing except that one part. So we can test that as well. So basically, that's how we can write tests and use our test client. If you're to notice, most of the tests that we wrote in this video are of the start of the application are just tests that use the test client. If you're making a post request, you provide the post data and then you do it normally. So in this case, we are sending it as JSON. Doing the same thing, get the book by ID, use the test client to get the book by ID, and then make assertions based on the result and what you expect out of that. So that is a simple setup. Now, what we're going to look at is an example that uses a database, and that is going to allow us to understand how to test a much more complex setup. So let's go ahead and do exactly that. In the following example, we have this simple application which builds on top of whatever we used in the first example. This application is making use of a database, and we're using SQLite for now. And it starts from the configurations here where we are using an async DB API. So I'm using SQLite with IO SQLite, which is like the driver or the DB API that we can use for SQLite with async IO. So this is pointing to the db.sqlite 3 database that we have right here. And then we are reading our config in our source config.py using pydantic settings. So if you're a little bit confused about what that is, pydantic settings is a package that is made by the same team that works on pydantic to manage settings. And the beauty about it is we can be in position to create a class that is a pydantic class, and then that class will be reading our environment variables from whatever configuration file we specify. For our case, we are reading all our environment variables from our .env, but this can be a .ini file, or there are very many files you can use. You can use a .toml file, you can use an env file, you can use a .ini file, and so on and so forth. Now, the only environment variable we're having here is the database URL environment variable. So if we add another environment variable here, we need to go ahead and add it to our config.py in order for us to not get any validation issues. Out from that, we have the init.py file, which is the entry point to our source folder, and this is where we have our FastAPI app or FastAPI application instance. So let me make this a little bit bigger so that you guys can see. Our application instance is found inside this file, and with it we have a lifespan event. Now this lifespan event is going to run throughout the application lifespan, and it's going to help us to be in position to create a connection to our database and create any database tables that may not exist within our database. Within that lifespan event is a call to the create connection function, and that function is one that we created to help us be in position to create a connection to our database. For to navigate where that file is, it's found inside the source db folder inside a file called connect.py. So right here we have that function, and all it does is to use our engine object to create a connection, import all database models, and then go ahead and basically create all of them in our simple SQLite database. But this setup can pretty much work for any database like MySQL with IOMySQL, and then Postgres with like async PG and so on. So when you go from the init.py, we have the db folder. So this db folder has everything to do with the database, including connecting, database models, and any dependencies that are going to be used to carry out CRUD within our database. So to start here, I have this standard init.py file, a file that I created to mark this as a package, but it's also where I'm creating my engine, and this engine is being created from the database URL environment variable I showed at the start of this section. With it, we are creating an async engine object, and we are providing the URL as well as echo equals true, but you can feel free to add any other keyword arguments that you may want to this call. Once that is done, we have another file called dependencies. Now dependencies is the file where we are creating this function that is going to be injected into each route, so that we can get access to a session and be able to connect to our database and perform an action. When you go to models.py, that's why we are having this book model. So it's the simple model we are using. This model has the same structure to the list of book objects or book dictionaries that I showed in the previous section. And this is the one that we're going to be having in our simple SQLite database. So the main application or API folder is going to be /books. You can feel free to name this to whatever you want or organize it in the structure you want. I'm just keeping a simple structure for the sake of this video. But this books folder has many files, but inside that we have CRUD. So CRUD is a class that is containing methods, and these methods are what we're going to be using to carry out CRUD on our database. So if you're to look at a method such as getAllBooks, this takes in an async session object, which is our session. Now this is what we expect to get from our dependency when we inject it into a route. So when you get that async session, we then create a statement, which is basically in the SQL Alchemy 2.0 style way of writing these queries. So this is the same way SQL model kind of handles the way we write queries, and we can create a select. And after creating that select, we then have to just use our session to execute that select, and then we get a result. So on that result, we can perform multiple operations like maybe a .all or a .filter or something of the sort, so that we get the result we want. And this is going to just be getting all books from the database or querying for all books in the database and then performing a filtering in case we provide a status. In the absence of a status, it's supposed to just return a list of all books that are present within the database. If we go to get book by ID, same thing, create the statement. After creating the statement, we go ahead and use the session to execute that statement, and then we return the result, and we get that specific object we want out of the result. So that is the CRUD class that is responsible for doing all our CRUD operations on our simple database setup. When you go to our routes.py, that's where the main application logic is going to be executed. And in that, we have our FastAPI endpoints. All of these endpoints are being created on a router object, and this router object is going to have the /books prefix. So similar to what we had in the previous section, our endpoints are now doing the same thing, but this time they require to perform some CRUD on the database. And each of the application endpoints is receiving a session object that is got from the function getSession, the one that I showed you in our dependencies. So whenever we get that session, we can then carry out CRUD on the database using a method we created on our book CRUD class. So this takes in the session as well as any other keyword arguments that may be needed. So that's our simple application. And if we are to go ahead and run this application with FastAPI dev source, our application will run on localhost 8000, and then we shall be in position to view our application. So I'll open this up in my browser. If I come to my browser right here, I'll then view the Swagger UI just like you see right here. So these are our simple endpoints. Nothing has really changed. It's the same application, but this time it uses a persistent data source. And that's what we're going to be testing in this section. To start our test, we're going to first of all create a file called pytest.ini or pytest.ini, which is going to be the main configuration file of our PyTest project. And this file takes precedence over any other test files that we may have within our PyTest project. So we shall always create it at the root of our folder structure. So that's exactly what I'm going to do. I'll create a new file and then call it pytest.ini. And in case you want to name it as a hidden file, you'll then have to call it .pytest.ini. But I will keep it to pytest.ini for this video. In it, we're going to first of all label it as a pytest config file, and then we provide the various options or various things that we may want to set up to change the behavior of PyTest. To begin, we shall specify which files are going to be recognized as Python test files. And for us to do that, we can just say Python underscore files, and then this will take in all files that will be recognized as Python files. So I'm having GitHub Copilot doing the copiloting for me, so just in case you're worried about the suggestions. So I'll go ahead and specify that all files that are going to start with test underscore whatever .py will be recognized as Python test files, and then all files that are going to be labeled with whatever underscore test.py will also be recognized as pytest config files. Another thing I want to set up is which folders are going to be recognized as folders containing Python tests. And the way to set that up is to write test underscore paths. And this is going to be similar because you have to just provide the name of the folders. So all our tests are going to be found inside tests, which is like the default folder PyTest will look for tests in. We can also provide other folders. For example, if you have an example underscore tests folder, we can also label it as a test folder by just adding the name inside our test paths. So I'll go ahead and remove this. Now, when it comes to our functions, all our functions by default, they'll have to start in test underscore and then the name of the function, and that will be recognized as a Python test function. But just in case we want to provide other sorts of files, we can also do that by using Python underscore functions, and then shall provide all the functions. So in this case, we have any function that starts with test underscore will be a test function. Any function that starts with whatever name underscore test will be a test function. And then same thing for a function that will be labeled with test. Another thing we can do is to provide command line options. So command line options such as the one we are using to run our tests, like the dash curve or pytest verbose, those can be added here. So let's go ahead and do that. We can just do something like add opts, which is add options, and in our case we can go ahead and provide what command line arguments we want to use. We want to run our tests verbosely, and then we can also go ahead and generate the coverage reports, and then we can also generate the coverage report every time we run our test. So in this case, we can generate our HTML report, and that will be the one to run our HTML report. Yeah, so that's the options we're going to be adding. Another important thing is going to be markers, and markers are just basically ways you can categorize or label your tests. Now let me demonstrate that with a very simple example. If you have tests that are going to be run in multiple categories or grouped in a certain category, then PyTest handles that by helping us to mark them with a marker or a name. So for us to create those markers, we'll just have to come inside our pytest.ini, and then we shall have to specify our markers. So if I provide markers, I can then go ahead and provide the name of the marker. For example, if a test runs slow, I can call it a slow test and then provide a simple description such as mark as slow test. And then I can also go ahead and provide maybe a unit test. So mark test, what am I doing here? So this will be marked as unit test, and then if we have any integration tests, we can mark them as integration test. If we have any API tests, we can then mark them as API tests, and so on and so forth. Now, with this configuration file, we have set up our PyTest. So let's say we are going to first of all test our markers. We have to make sure PyTest is installed first before we actually do anything. So we need to go ahead and install the following. We shall install PyTest, and then we shall also install PyTest async.io followed by PyTest curve. So PyTest async.io is the plugin that we're going to add to PyTest to help us test asynchronous code. And then pytest curve is what we looked at in the previous section, which is a plugin that we're going to add to pytest so that we generate a coverage report for our tests. So I'm going to go ahead and press enter. This has to install them within our virtual environment, but since I have all of them, it will just skip and that will be our installation. So once this is done, then the next thing we're going to do is to go ahead inside our project root directory. I'll create a new folder, and that's going to be our tests folder. I'll mark it as a Python package by introducing a danda init.py file, and I'll also create our tests file, which is going to be test_book.py, or let me just call it books.py, where all our tests for books are going to be found. Before we proceed to make any tests on our API, I thought it would be a very good thing for me to show you how pytest markers work. So I've created a simple function here called add, and it takes in parameters x and y, then returns the sum of those two parameters. Now, I've gone ahead and written some tests, and these tests are just simple tests, but one thing you will realize is you're using a pytest.mark and then the name of the marker that you set up in the pytest.ini file to group that test under a certain group of tests. So the way we're going to be running these tests is through the use of pytest. And in case we specify the marker with -m, we can then mark a test as a certain test marked by a certain label or marker, and then we shall see that test passing or failing, but the other tests that do not have that marker will be deselected. And in case we try to maybe run it with unit, we shall then be able to only run that one test that has the label of unit or the marker of unit. And then if we are to, let's say, run our slow test, that test will run and the rest will be deselected. So if we are to only run pytest, then all tests within our test suite are going to run and all of them are going to pass. So I just wanted to demonstrate how markers work and how they help us to group tests using markers. So I hope you found that useful. Now that you've been able to do that, let's go ahead and test our API. So the first thing I'm going to do is to close some of the files I have here and maybe remove some of the code I have here. And then I'll head over to our project structure right here. What I'll do is to go ahead and inside our test folder, I'll add the file called conf.test.py. So just like I explained, conf.test is the file where we are going to write functions, and these functions are going to help us to be in position to make sure that we create those variables or objects that are going to be used in our tests. Now, the first and most important fixture we're going to need is going to be the test client, which is going to allow us to make requests to our API without our server running. And for us to create that, we are first of all going to import the FastAPI TestClient class from FastAPI.TestClient. And once that has been imported, we shall then also import our app from source. And once we've imported that, then we shall also import pytest. So we're going to create a fixture similar to what we had in the previous section, where we went ahead and just decorated our function with pytest.fixture. But then what we're going to do is to specify the scope of this fixture. So pytest allows us to basically specify the scope of a fixture. By scope, I am meaning how big is this fixture going to be used, or how large in our project is this fixture going to be used. So fixtures can be created every time we run tests, but they can be created on a certain scope. So by scope, we have scope such as a class. So if you have, let's say, class-based tests, then you can create a fixture that is specific to a class, and this will be created each time you're testing that class. For a module, the fixture will be created when you're testing a module. For example, this is a testbooks.py file. So each time that tests or the tests for that module are going to be run, then PyTest will be in position to recreate that fixture and tear it down after the tests for that module have been run. For package, this is where the fixture will be created and torn down when the test for an entire package or a set of Python files has been run. Then session is the scope where we have the fixture being created at the start of this test session and torn down after the end or at the end of the test session. So this means that that object will be shared across the entire test suite. So what we want here is to set this as a session scope, or set this fixture to be present in the scope of the session. Why? Because this test client is going to be used throughout all the tests that we're going to write for this simple application. Now I'm going to create a function, and this function is going to be called the test client function. And here is where we're going to return our tests. So I'm going to be writing this with a synchronous context manager. So I'll say with test client that we're taking our app as our client. We are then going to yield our client, and that will be just enough for us to return our client object. So when I'm done with this, I'll then proceed to go ahead and write our first test. I'll go back to our test books, and then I'll write a test that's very similar to what we did in the previous videos. I'll write a test function def test get all books, and then this will take in our test client, and then we shall need to make a request to our API. So I'll create our endpoints to be located on base URL. Since all of them have the books prefix, I'll say this is going to be on /books, and then I'll come here and use our test client. So I'll say test client.get, and then I'll provide our base URL. So that will be on our root endpoint. And once I'm done with that, then I'll proceed to make assertions. So the first assertion I'll make is if the response status code is equal to the expected status code. So for that case, I'm going to make use of FastAPI status module to access that specific status. So I'll just come and say status.http 200. Okay. And then we shall also check the length of the JSON. So for this case, we're going to be making use of the same database we're using for the application, and therefore want to check if the response JSON is going to be having some data. So we can just say length of response.json is greater than 0, and then that will be showing us that our return JSON is going to contain some data. So once that is done, now let's go ahead and try to run this test. So I'll pull up my terminal and then run pytest. And now we shall see that our test is now running. So what we have done is to get our test client fixture, provide it to our test function, and then use that to make a request to our API, and then we make some assertions. But the problem is that this test is now using the same database that we are using for our application, which is disadvantageous because we do not want to deal with the data that's present with the database that we're using for our application. Now what we're going to do is to make sure that we override some setup configs, or some of the things we use to set up our database, and that's what we're going to be doing next. So this is where we are basically setting up which database we're going to connect to. Now, if we want to set up the one for testing, I'll create a test database URL environment variable. And then I'll name this to test db.sqlite3. And once I'm done with that, I'll then move to our config in our source folder, and I'll do the same thing, but this time this will be our test database URL. So once that is done, the next thing is to go to our connect.py, because that's where we have the code for establishing a connection to our database and creating any tables that may be present within our database models. So to do that, I'll go to connect.py. I'll copy this exact code, and then I'll go back to our conf test.py. Now this is very important because it's going to be the one to set up the tables and establish a connection to our test database. Another thing we want to do is to go ahead and modify this fixture, because it's an async fixture, but since we are running some async code, then we need to modify it to become an async fixture. So the way we're going to do that is to change this from def to async def. And right after doing that, we shall also have to change the decorator that we are using to make that fixture. So I'm going to rename this to pytest async io.fixture. So the scope will still be remaining as the scope session, as the session scope. I'll then go ahead and also import pytest async io instead of pytest, but in case we have any other things or fixtures we may want to set up that use pytest, then we shall import pytest. Now, one thing you'll notice here is we do not have SQL model imported, so I'll use my quick fix to import that very fast from SQL model. Another thing I'm going to need is to create a test engine for testing. I'm going to come right here and I say test underscore engine. It's going to be create async engine. So if you're wondering where that will come from, it's going to come from SQL alchemy.exe.async.io. So to import that, I'll say from SQL alchemy.ext.async.io, we shall import the create async engine function. And now what we need is going to be the DB URL that we set up in our config. So I'll have to go ahead and import our config object. Because we've set that in our config. Right after doing that, our DB URL is going to be equal to config.test database URL. So that's what we're going to need. And right after doing that, we shall go ahead and set that up as our URL. So I'll say URL is going to be equal to DB URL. And once I've done that, I'll also provide echo equals true so that you can see any SQL that's going to be generated when we interact with that database. Now I'll need to change from engine.begin to test engine.begin so that we can finally use our test database. So let's go ahead and try to run our tests using this simple setup. So if I pull up my terminal right here and run pytest, we'll now notice that our test is going to pass. And if we were to go back to our test, I actually named that test box. That test is going to pass, and we see that our last assertion, which is checking if there's any data returned in our response, is also passing, which means that we are still using the same database that we set up to be used by the application we are testing, which is not good. So the reason as to why this is happening is because all the endpoints we set up are making use of a session dependency that is being injected into each of the endpoints. If I take you back to routes.py, we'll notice that each of these are going to have the session dependency, but this session dependency is going to come from the get session function, which we created in our DB dependencies. So what we need is to go ahead and create a session or a mock session or a session override that is going to override this session and help us to only use the database that we've set up for our tests. So let's go ahead and do that. I'll close some of the files that we have here. I'll copy the same code because it's going to be almost doing the same thing, and then head over back to our conf test. And inside our conf test, I'll then go ahead and simply create a session to override the default DB session. So I'll paste this code right here. So we need to import quite a lot of stuff, and I'll begin by using some of my quick fix to import some of them. For example, this is a simple import, and then for the session maker, I'll have to import it from here. Now what else is not defined? Our session. So we need to use the test engine object that we created here to go ahead and create that session. So let me go over what we've so far done. We have gone ahead and created a test database URL environment variable. We've then gone ahead to create our test engine, which is going to be creating a connection to our database for testing. And then we've used that to create a test session that we're going to be returning inside a dependency. Now I need to rename this to our get session override. Or we can even name it the mock get session or test get session. And once this is done, we can now go ahead and rename this or override the default session. And FastAPI allows us to do that through a dictionary called the dependency overrides dictionary. And how that works is you get the key of the dependency you want to override, and then you provide the value for the new dependency that you want to use instead of that dependency. So before we yield our client, or before we use our test client to create a client with that app instance, we can then go ahead and add a line. So this is going to be the one to override the session. So we can do that with app.dependency overrides. We set the key. So the key is going to be the get session dependency, the one that we created in our source DB dependencies. And then we shall substitute that with the test get session, the one that we've created right here in our conf test. So I'll go ahead and use quick fix to locate that and import it. That's going to be found in source DB dependencies. And then I will save. And now after saving, I will try to run pytest again and see what that will return. So if I run pytest, this time we shall see that our test is failing, meaning that our response is not returning any data, but our assertion makes us test if there's any data returned with our response. That's why you say that the length of the response JSON is 0 and the expected is 0. So for now, we want to go ahead and assert something else. I will just change this to just check if our response.json initially is an empty list. So when I go ahead and save and run our pytest once again, we'll now see that our tests are passing. So that is what we're going to be doing. And for now, we are using our test database. In fact, if we go back here, we can now see that our test db.sqlite3 has been created. Now, If I want to check our coverage report, I am going to just go back to my HTML coverage folder, and then I'll go to my index.html and open this up with Live Server. When I open that right here, I'll then proceed to the HTML coverage folder. And now I'll go to our routes because that's what we are testing. And now we shall see that we've so far been able to only test one specific part of our routes. So that is the one to get all books, and we've so far tested only getting books. So we need to make some assertions that check for our books that are being returned. So given this, we can then go ahead and test using our test database, and I'm going to save time by speed coding all those tests. Okay, so these are the tests we've so far written for the application, and they are very similar to what we had in the previous example. To take you back to our conf test, we recognize that there are some other fixtures we've created. For example, we have a test book payload, which is basically a dictionary containing book data that will be used to create our books. We also have the test book update payload, which is the payload that will be used to update a book. When we go back to our tests, we are now having that being passed through those endpoints that will need a book object to be created. Now, since we can't keep track of what UUID we shall have for each of the posts each of the books we're going to have in our database, all we are doing is to insert one each time we want to, let's say, retrieve one by ID. For example, this, instead of just being test create book, it is test create get, because what we are doing is to both test the endpoint for getting or creating a book, and then we are doing the same thing for getting a book. So what we do here is to create the book, assert if it's created, and assert if the data we've provided is the actual data from our test book payload. And then we find out that that will pass. After doing that, the response will give us the ID, and that ID is what we'll use to go ahead and still test if when we get that book, we can be able to get the exact book. So that's what we are doing here. We're then testing some edge cases. For example, when someone provides invalid data, what are we going to do? Or what response are we going to get? So in this case, the API should return an processable entity, and then should also throw an error, sort of like a validation error, which will provide a message. So we go ahead and carry out those assertions. So it's always important that you first test your API manually so that you can understand what your API endpoints are going to return in case you perform all these actions. So that's exactly what we are testing right here. Then we test the book not being found by providing a wrong UUID that does not exist in the database. The status code is going to be not found, and then we basically return the detail of that response. For get all books, we are just doing the simplest request, which is getting the root URL and then asserting if the status code is okay. Get public books, we are just providing a param in the same request for getting all books, and then same thing for private books. Now, providing an invalid status, of course, we expect the API to give us an error, and that's what we are asserting here. So the moment you provide an invalid status, if you are using an enum, the API should go ahead and throw an error that tells you that the status you should be using should be part of the items that are present within the enum. Another thing is when you are updating a book, we are using the same flow. We first create the object, and after creating the object, we get its ID and then use it to update the object. But remember, we have that fixture for updating a book, and that's exactly what we pass on to that specific request. And now we see our status being returned as 200 okay, and then we check if the book contains the data we've used to update the object. We test if the book is not found. So I've also gone ahead and added some catches or some error handling to our API endpoints. For those that are retrieving a book I had forgotten to add that check that checks if the book is none, because if we are to go back to CRUD, we can see that in case an item is not found, then some endpoints are just going to return none, and in case they return none, then we shall not have any error handling. So that's what I've done this side, added that extra error handling, and then that will show a status code of not found. So those are some of the things that I am catering for back here in our tests. At updating with an invalid payload, still we want to see what will happen, and that will return an processable entity with an error of field required. So yeah, that's how we are writing our tests. And if we go ahead to run these tests with pytest, we'll now see that our 12 tests are now passing. So what we've done in this video is to look at how we can test our API using pytest, and we've looked at very many features of pytest that can make it easy for us to test our API. We've used FastAPI TestClient to help us make requests to our API and get responses, which we can then use to make different assertions. This is just part of integration testing, and there's so much to the topic that I can share beyond the scope of this video. If you've enjoyed this video, please leave me a like. Do not forget to subscribe, and please like the video if you can, because that's the only way you can support me. And thanks for watching.